Is math just about getting the right answer quickly? For a lot of us growing up, math felt exactly like that. Just a high stakes race to the finish line where whoever finished first was automatically the smartest. But what if we've been looking at it completely wrong this whole time? What if true math is actually about slowing down, really noticing the world, and building a structured toolkit for thinking?
Welcome to The Explainer. Today, we're diving into a genuinely fascinating source called Numbers, Notebooks, and Night Skies. Now, technically speaking, yes, this is a second grade math guide. But honestly, its philosophy is so incredibly foundational that it holds major value for learners of literally any age. It completely reframes how we look at numbers, showing us that math definitely isn't something to fear. It's actually a secret decoder ring to describe, organize, and make sense of the everyday world right around us. So let's jump right in.
Here is our roadmap for today. First, we'll look at the math mindset. Then, we'll cover building block numbers, math in the real world, shapes and equal shares, and finally, stepping stones to multiplication. Kicking things off with Section 1, the math mindset, noticing, thinking, and explaining. Math is not a race. That simple little sentence perfectly captures the core philosophy of our source material, and it is just so powerful. The text points out that careful, deliberate thinking is way more important than just rushing to an answer. A truly strong math learner is someone who asks questions, someone who tries different ideas out. If a problem feels super hard, you don't panic, you just try a new strategy. You draw a picture, make an estimate, or maybe break the numbers apart. And hey, what if you make a mistake? Well, the text makes it wonderfully clear. A mistake just means you skipped a step, or maybe you mixed up two numbers. It absolutely does not mean you're bad at math. It's simply a fantastic opportunity to look back, figure out what happened, and learn something useful for next time. Moving right along to Section 2, building block numbers, place value, and operations. Now notice how a huge, intimidating number can suddenly become totally friendly. Let's look at the standard form of 347. To a beginner, that might just look like three random digits smashed together, right? But look at the expanded form right below it, 300 plus 40 plus 7. It's not just a 3, a 4, and a 7. It is exactly 3 hundreds, 4 tens, and 7 ones. The physical place where a digit is written changes its entire value. The source also highlights the absolute importance of the number 0. Think about the number 506. That 0 is completely crucial because it tells us there are absolutely no tens. Without it, 506 would just be 56, which is obviously a totally different value. Seeing numbers broken apart like this, it just takes the intimidation factor completely out of the equation. Let's see how this builds when we get to subtraction. Subtraction with regrouping, or, borrowing as a lot of us learned it back in the day, used to feel like a confusing magic trick. But check out these logical steps. Let's say you have 52 minus 7. Well, you can't take 7 ones away from 2 ones, so step 1, break apart 1 10 into 10 ones. Your 52 becomes 4 tens and 12 ones. You'll literally still have the exact same amount. You've just grouped it a little differently. Step 2, subtract the ones. 12 minus 7 is 5. Step 3, subtract the remaining tens. 4 tens minus 0 tens is 4 tens. Put it all together and you get 45. The source actually says it perfectly. Breaking apart a 10 isn't a trick. It is simply a place value idea. Let's step into Section 3, math in the real world, measurement, time, and money. So the really crucial point here is that money is basically just place value that you can physically hold in your hand. We've got the penny, the nickel, the dime, and the quarter. But there is a totally surprising real-world fact highlighted here. The dime is actually physically smaller than a nickel, yet it's worth twice as much. That clearly demonstrates exactly why we have to understand the actual mathematical value of the coin, rather than just guessing its worth based on its size. The source also gives a super handy tip for adding mixed change. Always start by counting the coins with the greatest value first and then work your way down. It's highly logical. Let's stay out in the real world for a second and look at time. A 12-hour clock can be genuinely confusing. I mean, why does 7 o'clock happen twice a single day? Well, this clarifies AM and PM perfectly by anchoring them to relatable daily events. AM is midnight to noon, like 8:30 a.m. when school usually begins. PM is noon to midnight, like 6:15 p.m., right around dinner time. The text really encourages learners to pause and just ask if a time actually makes sense. Like, would you normally eat your morning pancakes at 8 p.m.? Probably not. Tying these abstract concepts to a regular daily schedule makes elapsed time and clock reading feel real, practical, and totally understandable. Section 4, Shapes and equal shares, the visual world.
Notice this definition of a quadrilateral. A shape with exactly 4 straight sides and 4 vertices, which, by the way, is just the fancy mathematical term for corners. That is it. It strips away all the confusing academic jargon. What's really interesting is how this gets applied in practice. A square is a quadrilateral. A rectangle is a quadrilateral. In fact, every single square is actually just a special type of rectangle that has one extra strict rule. All 4 of its sides must be exactly equal in length. And the source makes such a great point here. Turning a shape doesn't change what it fundamentally is. A square turned on its corner to look like a diamond, still a square. You define it by its mathematical properties, not its physical position.
And that brings us right into fractions, or what the book affectionately calls equal shares. We have a fantastic visualization of fourths. The absolute golden rule, as the source text continually stresses, is that every single piece must be exactly equal in size. You cannot have 3 tiny slices and 1 massive slice and still call them fourths. No way. If you break a whole into 4 perfectly equal parts, each part is 1/4. And you can visually see how all this math connects. 2 of those 1/4 slices cover the exact same amount of space as 1/2. It builds this really strong, intuitive visual sense for fractions way before anyone has to look at complex equations.
Finally, we arrive at Section 5, Stepping Stones to Multiplication, Patterns and Grouping. Notice this comparison between even and odd numbers. It redefines them not just by checking if the very last digit is a 0, 2, 4, 6, or 8, but by the highly physical, visual act of making perfect pairs. Even numbers can be divided into 2 equal groups with absolutely 0 left over. Think of it like having 14 students who need to form partner groups. Everyone gets a partner. But odd numbers, you are always going to have exactly 1 left over when you try to make 2 equal groups. If you have 15 students, 1 person is left standing there without a partner. It brilliantly grounds a mathematical rule in a reality that you can literally see and touch. Let's move to our final conceptual point to see how all this grouping builds directly into multiplication. Look at this arrangement of stars. This is called an array, basically objects arranged in equal rows and columns. We have 3 rows going across with 4 stars in each row. Using repeated addition, 4 plus 4 plus 4 equals 12. But if you look at it up and down, you have 4 columns of 3 stars. 3 plus 3 plus 3 plus 3 also equals 12. This visually proves that the total stays the exact same, even if the groups are arranged a bit differently. The text notes that this is the gentle, friendly first step right into multiplication. It proves beyond a shadow of a doubt that 3 times 4 is the exact same amount as 4 times 3. It's all about encouraging true, deep understanding rather than just rote memorization of symbols on a page. Which brings us to our final question for you. How will you notice the math in your everyday world today? We've seen from this fascinating explainer that math is so much more than just a speed race for numbers on a piece of paper. It's a lens for looking closely at the world. From the rectangular shapes of your windows, to the elapsed time on your morning clock, to the equal shares of a meal you might split with a friend tonight, I really hope this deep dive has inspired you to slow down, embrace the messy learning process, and start seeing the beautiful mathematical structure that literally surrounds you every single day. Keep noticing, keep thinking, and definitely keep exploring.